In Year 13, we study nucleophilic substitution reactions of the amines. The mechanism for this is exactly the same as what you learnt in Year 12, it's just that the nucleophile is the amine, which is slightly more complex. So we're going to use, as our starting material, so we always start with a halogenoalkane. In this case I'm going to use 1-bromopropane, and our nucleophile is going to be ethylamine. So ethylamine has got the amine group attached to C2H5. So in the first step, lone pair from the nitrogen, I must remember the partial charges of course on my halogenoalkane. In the first step, the lone pair from the nitrogen forms a new dative covalent bond with the electron deficient carbon, and this causes the bonding electrons from the CBr bond to be pushed towards the bromine. So we end up with our product, which is, it's just simply had the bromine has been replaced by the amine group, and we have created a secondary amine. Well, it's actually, at the moment it's an ion, so we'll come to that in a moment. So we've got our C2H5. There's a positive charge on the nitrogen because it has effectively donated one of its electrons to the carbon in the forming of that bond, and we have a Br- ion as a byproduct. Now, if there is an excess of ethylamine in the reaction mixture, then what will happen next is that a proton will be removed from this positively charged ion to leave the secondary amine, the proper secondary amine. So I'm just going to show that now. So we have another molecule of ethylamine, and what happens is the lone pair from the nitrogen will form a dative covalent bond with a hydrogen ion from this, and that causes the bonding pair from the NH bond to move to the nitrogen to replace the lost lone pair, and we end up with our product, which is a secondary amine. So depending on the reaction conditions and the proportions of the reactants, we can then end up with a further substitution occurring. So this product could then go on to react with another molecule of bromopropane to replace this remaining hydrogen, or indeed the tertiary amine could act as a nucleophile, react with an additional halogenoalkane molecule to make a quaternary ammonium salt. So further substitutions can occur in that way.